the Pythonic requirements of TestStand and LabVIEW. So basically, what the journey up until now on what I learned when trying to integrate Python into either of the products for 2019 to 2021. It's an advanced topic because it's more related to installing Python in the right way that works with LabVIEW and TestStand, and not so much focusing on the writing Python code. If somebody expects that, there'll be several different parts for that. We'll be a bit pressed on time, so as I said, please use the Q&A feature, and I'll try to get through them as fast as possible. Good. So with that in mind, let's get started. My name is Jesper Kjær Sørensen. I work as a systems engineer at G-Power. I am a certified LabVIEW developer and TestStand developer, and I've been doing Python since 2012-ish. I started programming in 2000, around my high school years, where I was programming AT32 megachips before Arduino even was a thing. We have to lift them off the board and put them on your own design board. And I hold a master's engineer in electromechanical system design from the University of Aalborg. Yeah, and basically in 2012, when I got my first Raspberry Pi, I started looking into these Python applications, both desktop, but also command line and web applications, especially during the COVID situation, where I built my own virtual farm show for all the farmers in Denmark to be able to attend, which was quite fun. Good. That's enough about me. For the Our Giants Are Female, I've chosen Lady Ada or Lemore Freed. She has a master's in engineering from 2005. She's the CEO of Adafruit Industries. She was elected the champion of makers in 2015 by the White House administration. And she's a big supporter of open source hardware and software. Mainly chosen her because her and her company makes or enables everyone to enhance their Halloween costumes with LEDs, which and blinking effects, which in my opinion is bringing a lot of curious minds into the world of STEM and the possibilities within there. So both male and female, and Adafruit also created sort of a female-directed approach, which was most of their marketing content and materials is also directed towards girls. So as you can see here on the image, it's a girl holding up the, or at least it's somebody with painted fingernails holding up the circuit board. So they're absolutely not scared about that, which is quite cool. So kudos to Lemore for building this giant company. For this talk itself, there are some preconditions. So basically, it's mainly the separation of concerns. How much should your application care about the environment that it needs to be installed in? Should we have you should be able to decouple your environment from your application. You should be able to identify the dependencies that are system specific versus the dependencies that are application specific. You could have some shared resources, especially Python, across your system. And you don't always have to pack the LabVIEW runtime. Whenever you deliver 5 LabVIEW applications to the same server, you would just do one install of the LabVIEW runtime. So this is a sort of a shared resource. On top of that, you should use packaging technology. There was a lot of presentations of those yesterday regarding the NI package manager, and that's also my weapon of choice in this talk here for application distribution. And it also supports creating the dependencies. What I learned yesterday was also that for the more specific parts where you need to do dependencies to packages that are not installed, you should use the command line interface for the package manager. That could be interesting. It's also a good idea to know a bit about these system paths, especially on Windows, the environment paths and environment variables, and of course command line interfaces. So if you're familiar with git add star, then you should be good to go on this one. For Python basics, if this code doesn't scare you, then that's basically what is needed. It's mainly the example that I chose to go with, just to see where the executable is and importing a module and so on. So what's actually the main problem in this that we're trying to solve here? So basically, what I found the hardest was installing and configuring Python consistently on a Windows system. It is really hard to make sure that it is set up in the same way every time. You could, of course, do it manually, but that just leaves it up to the developer to remember to do it the right way at the same time every time. And mainly this is sort of a myth that it's hard to install on Windows because it's usually been, or the most outspoken Python developers have usually been people using Linux or Mac. So, and there it comes built in, but with its own set of problems. So it of course also needs to be scalable. We need to be able to develop something that we can install on your development system, but also distribute to either 1 or 10,000 development systems, including a Windows PC here. So that should be quite easy. And for that, we will be using NI Package Manager. Then there's applying some of the common practices in Python when it comes to handling the things like virtual environments. It's unclear how to do that, particularly in LabVIEW, and I'm trying to do my best to go through that here. LabVIEW only supports function calls at the moment. But TestStand has a more full Python adapter, and that supports a lot of more features, both calling classes and so on. I'll come back to that. And last but not least, LabVIEW and TestStand call Python in a different way. LabVIEW uses, at least up until LabVIEW 2021, it uses the Python on the Windows path, so the globally installed Python. And that's also where you need to install your packages, whereas TestStand supports virtual environments as long as they are created in a very particular way. So would there be some way using NI Package Manager to define Python as a package that I could include in my installers? And of course there is, otherwise I wouldn't have made this talk. Last but not least, so the LabVIEW examples in Python doesn't work out of the box on a blank PC, which of course makes sense because you don't have Python installed, but the error messages regarding that is not super helpful. What you'll be able to see is this, that it cannot find the DLL file, which I'll also come back to, which is a quite cryptic message on that issue. And sometimes you actually, during this, or at least several times during this talk, I felt a bit like Indiana Jones, going through all the dungeons and trying to figure out where's the next trap that you're falling into. So that shouldn't be the case. So by the end of this talk, we should be able to install and manage Python through NI Package Manager. We should be able to expand Python with third-party applications and packages, also in offline situations. Sometimes your test station is not connected to the internet. And we should have consistent environments both for development and production, because we want to test particular features on development before going to production. And of course, we should be able to do one of these two scenarios, which is run some Python code from our project with a function in LabVIEW the right way, and then of course install and use or set up and use the Python adapter in TestStand here. So first of all, let's have a quick look at what's a Python environment. Python environment is the interpreter, it's some third-party packages, and it's your custom functions. For the interpreter, NI chose to implement CPython mainly because it's the reference implementation and it is installable on all systems. There are other interpreters like Jython for the Java implemented one. There's PyPI, which is actually a Python JIT compiler, or a Python-based JIT compiler. And then there's Anaconda, which is a 2 to 4 gigabyte distribution of several versions of Python and Fortran compilers and a lot of other stuff that is mainly used in data science. That's currently not supported by LabVIEW, and I think they're working on it. For the third-party packages, there are several. So if you hear stuff like NumPy, Matplotlib, or in this case Django, which is a web framework, numerical Python, or plotting in general, just like you would have in MATLAB, then you would use these as some of the third-party packages to enhance your environment with using all of these new features that are not commonly installed in Python. And of course, something to tie it all together. So in that case, we need a test, or not a test file, but we need a Py file that, in the same way as we need AVI to build an application in LabVIEW, we would also need a Python file to collect all of this. In this case, I just called it test.py. So first of all, packaging up the installer. Let's start with putting the Python installer inside an NI package. Maybe a short word on compatibility here. I haven't been able to find an NI compatibility chart, which would have been useful for this presentation. But as we can see here, LabVIEW and TestStand both support 2.7 up until 2021, actually. They support 2.7 and from 3.6 and above. And for LabVIEW, we have 2021. They dropped support for 2.7 for a very good reason. 2.7 is dead. It died on the 1st of January 2020. So if you get any requirements for running any 2.7 related stuff, please require them to update to something that's more safe than this. Good. And last but not least, as also was mentioned yesterday during the C calling C functions discussion, 32-bit Python goes with 32-bit LabVIEW and TestStand. So please remember to match your bitness, otherwise you'll get a different set of errors. And that's not easy to figure out. Good. So that being out of the way, we would like to install the interpreter consistently. So in order to install it consistently, you could use a command line interface where you have the Python version.exe for the installer that you download. This is the Windows installer. You would have an action and then some sort of configuration setup. So if we didn't want any interactive usage from the users, but just wanted to show the dialog, we would use this, in this case, 398 we're installing. We'd use the passive flag and then direct it to a target directory. We would need to prepend it to the path in order for us to be able to run Python on the command line, not having to put the Python, the path to the Python exe file everywhere. And then we would precompile all the nodes or all the Python files inside the standard library just for faster execution. If we didn't want to use the user to see that during the installation, we would just use the quiet option, but or the quiet action, but the options are the same. And we should also add an uninstall, or at least need an uninstall in order to remove Python again. So This solves the following. We can install C/Python39. It precompiles, as I mentioned, and it adds it to the system path. So everything should be peachy from there. There's a complete list of all of these options at this link that I will provide, and I'll also upload the slides to LabVIEW Wiki. So putting it in a Python in an NI package, we could abuse the LabVIEW project a little bit by creating a folder structure and putting in the installer.exe file and a README next to the file itself. And then we have this unattend .xml file, which is basically all the configurations that we want to use. If you use the link from before, it provides a description of how to set all of these options in an XML file, and that makes it easier to install it consistently. You should definitely run this through your source control for your distribution. So we'll then create a build specification for the package. And in here, basically, we just put all of these in a folder somewhere where we can find them again. We need to keep the exe file in order to do uninstallation. So we should, in this case, I just put gpower and then Python. And then I have my installer, my unattend file, and the README, just in case somebody manages to go through there and have a look at what's there. We also need some custom actions. So at post install, once the files have been copied there, we want to run the installer with a passive argument that will then read the unattend.xml file and then install it with all the flags I have in here. On top of that, we have the uninstall, which will uninstall Python, the Python interpreter that is installed on the system when we do an uninstall of the NI package. So now that we have that part out of the way, we should be able to install this on our development system and see that it works, and we now have Python 3.9.8. So we could then use that package in order to build the next step of the way, which is packaging up any third-party packages that we need as a requirement for our application. So first of all Python environments should have a requirements.txt file that describes what packages in what versions and preferably with what hashes are needed in here. There's no hash in the example code. This is just taken from the requirements file formats description. But as you can see, we can specify the version, we can specify a minimum version, an excluded version, a compatible release, or other requirements files. And last but not least, and most interesting, is that we can specify a local file as well on our PC. So if we go through how to install all of this, we can see that in the command line, we have to use Python -m to run a function as or a module as an application, and then some sort of module options, just in the same way as we did for the installation of Python. So if we wanted to install a single package like NumPy here, we would just write Python -m pip install NumPy. Pip is the Python package manager that takes care of putting the files in the right directories and downloading it from the Python packaging index. And if we took our simplified requirements file, we would put two packages in there. One is called virtual env for creating virtual environments. That is relevant for TestStand. I'll come back to that part in the next slide. And then there's NumPy that we need for some numerical calculation. And if we want to install the requirements file, in this case, we would run Python again, Python -m pip install with an -r flag. and then the path to the requirements.txt file. So basically, this command would be handled right next to the requirements file in this case. You could also take a different approach. You could download all the packages to a specific folder by running Python -m pip download -r requirements.txt, and then add this -d local folder path, where you put in the path to where you want to download them to. And that actually makes it quite easy to take all the content of this and put it in an NI package. So how to install it if we don't, all of this has been connected to the internet up until now. So what if we need to do it from our offline situation? Then you would use a different installation flag or an extra set of flags. As you can see, we've just added to this one the no index flag, meaning that it will not go to PyPI, and then the find links to a local folder path that we can access. And that's necessary if we've distributed all the packages in a version that we would like. So we can do all the vetting of our packages and do the downloads from there. Yes. Moving on with virtual environments. Virtual environment is a way of isolating two different versions of a given package. In this case, we have on the same PC, we have NumPy, and we have in version 1.21, and we have NumPy in version 1.19. And they can coexist on the same PC, but they cannot coexist in the same environment. So that's why Python has the virtual environments, and I'm quite sure that's also what we would like to have from the Project Dragon. So at some point, that will hopefully be available for LabVIEW as well. So for virtual environments, again, it's a Python instruction that we install this virtual env package. And in order to run it, instead of, as you can see here, instead of pip, we run Python -m virtual env, and then the name of the folder, I use .virtualenv or .venv as my convention of folder names. So if I come across a folder that is named .venv, I know that it is a virtual environment, and that is a disposable thing that I can delete and recreate if I want to. And then I need to activate it. And once it's activated, then I will have this prepended to my interpreter, or not interpreter, in my terminal, and I will be able to see that I'm inside the environment now. I can install all of my packages from my local repo or the internet, depending on how much I put here, and then put this inside my .venv lib site packages. It's basically what the pip does. I have put a recipe on how to do this, but since we are a bit pressed for time and we would like to go through the demos as well, I will skip this, but you will be able to read it. Most important part is that you should have Python installed before starting all of this. And you should, of course, use semantic versioning. So this is quite trivial, and nobody should have any problem with that. Next is the more interesting part. So launching the environment from Python or from LabVIEW and TestStand. So now we have a package with a LabVIEW, or no, a package with Python. We have a package with our NumPy and downloaded packages. And we could, on that, use those two things to create our virtual environment, and then we need to call those from LabVIEW or TestStand. So we're ready to work with that. And from TestStand, you can call or set up the virtual environments and the interpreter from the adapter configuration. So you basically set up whether it should use a global Python interpreter, one per execution, or one per thread. So Python has historically been known to have this global interpreter lock. and that is where you, no matter how many threads you created, it would lock. It would only have one interpreter, and that would cause some of these problems here, where it would lock up the threads and the thread would have to wait on top of each other. That is not the case in TestStand because they wrap the Python interpreter itself. So in TestStand, you have the option of running several Python interpreters parallel. You would select the Python version here, and you could select a virtual environment here to use for your test running, or the test sequence that you're building. And then you have, for instance, a Python action step where you would specify a module, and you would specify the operation scope, because you could both work on the module itself. A module is a Python file or .py file. The module contains classes and functions and module variables, and TestStand actually supports all of these, also calling methods on classes, but it doesn't support calling the specific Python class method, which is working on a non-instantiated class. So that would be impossible to do in TestStand at the moment. But I know they're improving features, and I'm trying to help as best I can. So coming back to this virtual environment, this is actually where it has to be a virtual env-based virtual environment. Otherwise, TestStand will complain that you're not providing the right environment. There are several ways of creating a virtual environment in Python, but for TestStand, you specifically need to use virtual env in order to do so. And they can be set either for the global interpreter, or in the case of the step itself, you have the option here as well. So that was TestStand. Let's move to LabVIEW. At least LabVIEW up until for 2019 and 2020, it used the global Python interpreter. And the way it's created is that you, as I mentioned during the start, you only call functions. So you can't call classes or variables inside your module. You can only call a function, which is anything that is represented with a def, def in front of the name. So that also means that you have to install all your packages globally in Python, or you have to modify, before you start your application, you have to modify the path in order to run with the system path. But that's not entirely enough, and I ran into some problems trying to do that. But luckily, they created version 2021, where you now have this Python path variable that you could set where you want to load Python from. But this is a path to the Python xy.dll. So what I thought here was that, okay, so this can actually point to my virtual environments. But it turns out that it's actually a direct link to the DLL file itself, the DLL you want to load the interpreter with. And that's not being copied when you do, for instance, a virtual env or a venv, which is the built-in version instead. So how to proceed on that part? We don't have any DLL copies here. My expected workflow when I went through all of this would have been install Python for Windows, create a virtual environment. I can do both of these. The first one with the package manager, second one with the command line or system exec, then install all the packages from my requirements. And then I wanted to run the venv from LabVIEW by pointing out this venv path and then using that. that was my expectation going into this. Kind of turns out that that's not entirely the way it works. And there is a workaround in order to get through some of this. If instead of using the Windows installer for Python that installs it globally, you can use the embeddable Python package, which is the bare minimums of running Python on your system, but that does not have this pip support. So installing packages requires you to change a set of files, and I could go through all of this list, but it's more interesting to switch to my environment and having a look at it. So let's do that for a second. Here we go. And just to check. Yes, wonderful. So when we look at this workaround here, just putting that up there as the first one, we would have our V and V is now this set here of functions that is necessary to run Python. It has a Python exe. It also has this DLL part that we were looking for before. And it's has a pre-compiled version of the entire standard library. But it doesn't have these two folders and it doesn't support pip. So in order to solve that issue, you need to go through this file here and change that. Just open it with Notepad. You have to uncomment this one, so remove the hashtag here. And then you have to download a file. There's a getpip.py, and then run that from your application or from the command line. And then you can actually do the installations, except you have to put, whenever you use Python or use the pip, you have to put scripts /pip in front of it instead, because it's not on the path itself. So that shouldn't be a problem on top of that. Good. So coming back to all the other examples here, the packaging of the interpreter just gives us the .py file here, just quickly showing this, quickly, hopefully it opens. Yes. So you should put the minor version here, because we don't care about the build number. That can be handled in the package version, but we could have 3.7, 3.8, and 3.9 in as separate packages that we need to install and manage correctly. So this is necessary, and specifically just to be able to figure it out later on, it's a good idea to put in the bitness as well. Yes, otherwise it's setting up the package itself, and the two actions that you need to go through are both either passive or quiet, and then uninstall. And that's basically it for the package. So if we take a look at the NI package manager, the resulting part will be this, where we have the Python as part of our application distribution, and an installed applicant here that we can basically work with. There's, of course, as Scott Richardson pointed out yesterday, this is only a wrapping of Python in order to install it easier. and that would there's nothing preventing somebody else from going into Windows and uninstalling Python, and that could cause a problem. But recreating the installed environment is quite easy based on this. So you should be able to get back up and running faster than trying to figure it out. And I can see the TestStand quiz is going live in 10 minutes, so I'll see if I can't wrap this up really fast. I think it was 10:45 the plan was. So let's see, here we go. Regarding our requirements here, let's pull up a package we can call. I haven't pre-installed Python on this one just to show. So Python -m pip install requirements. This should install all our requirements here. We already have some of them installed. I didn't clean up my VM correctly. And this would install all of these packages, all of the ones named here. Basically, this is an output from a tool called pip tools, where you can use these pip compile, which is a way of taking the top level requirements in your requirements.in file and then putting it, getting a requirements.txt file, which is the one being used by all developers. That's also a good practice. I just didn't have time to fit it in the slides, so I chose not to. And of course, if we wanted to create a virtual environment in here, we would put virtual env dot env. And it should create a package or a virtual environment in here where we have all the things we want to install later on. We can activate it by .venv slash, come on, be nice. So now we're inside the virtual environment and we can deactivate it. Now we are outside the virtual environment. So that was actually what I wanted to use in LabVIEW to be able to do these things. So if I run my, where is it? Here we go. So wrong LabVIEW project. Here we go. So in this example code where we call a function inside Python, it's pointing to the venv directory from my application root. It's pointing to the venv directory and the Python 3.9 DLL. You can't just point to the directory at the moment. It needs to be the exact DLL path. And it just calls this testcode.py. And I've pulled up the test code here. For running this NumPy test, it just imports NumPy inside here. And that was because I wanted to be able to run both the get system version or the get executable that I showed in the slides, as well as the other one with the NumPy part. And for TestStand, just wanted to show where you would go to configure this adapters and then Python you would set your virtual environment here for your package and or for your adapter. And right now I just put it next to my project file, but it could be, there are better ways to do that as well. This was just for show and tell. Good. I think that is all except the last slide. So come on. Here we go. And so what we went through here was we were able to install and manage Python. We could now expand Python with third-party applications or third-party packages. We could have consistent environments, both development and production, because I could just install the same set of packages on my development machine. And this should enable you to do the scenarios below here by loading Python specifically from a DLL path in 2021, but also just from the global one, and calling a function from some code that you have available in your repo. You can expand the arguments here for calling the code. And in the same manner, run a virtual environment in TestStand. So let's switch to the questions part. We have about 3 minutes left for question. So from the Q&A parts, Eric asks whether, so Python is prepended to your path, and when you run the activate script, all the subsequent Python commands from LabVIEW will execute in your virtual environment. Yes, that is the idea. The problem is that that's not support. Virtual environments is not supported by LabVIEW at the moment. I know NI is working hard on doing that. But the way it's implemented, it only works on the global Python. And when we do the installation of the package, it installs Python or it adds Python to the Windows path. So you have access to the Windows version of Python that we install. So I hope that answers your question. There's a question from Georgios. For clarification, Python 3x ships with the VNV method for creating virtual environments. That's what you'll all see in the documentation and examples. Yes, especially for TestStand, this virtual env is a superset of the built-in VNV module. And it's definitely necessary to separate the virtual environments in your test systems. There was a second question from Felipe. I don't think the question is what about the usage of pipenv using pipenv.run? Currently, that is not supported. I believe that it was added under the Python packaging authority. The support for using this pipenv project, but the part is not supported by either LabVIEW or TestStand at the moment. And the number of new package managers in Python, or not package managers, but virtual ways of creating virtual environments is growing every day almost. So if there are additional stuff, it's quite hard to get it to work with LabVIEW at the moment, and TestStand for that matter. Good. Any other questions or clarifications needed? There was another question. So currently we can only install one version of each package for use in LabVIEW. That is correct for LabVIEW 2020 and 2019, yes. There you would use the Python that is on the path. Unless, of course, you want to get into the installing Python without having it on the Windows path. And you install the Python interpreter in different places. That could also be done, but that would then it's up to you to manage the system environments, and it's not just the system path variable as far as I remember. So that's some of the extras you need to dig into, and that's probably missing a bit of documentation on what actually is being looked for in LabVIEW, especially in LabVIEW. In TestStand, it's a bit more forgiving, and on Windows you also have this Py launcher, PY, which supports selecting the various Python interpreters on the system, but that is not supported by either LabVIEW or TestStand at the moment. So switching is internally in LabVIEW or TestStand by these constants, or selecting the version in the Python adapter or step settings for TestStand. Not entirely sure whether it cares if Python is on the path. If you don't specify the specific DLL path is or specifying the DLL path is an optional input. So if it's supposed to work without specifying the DLL path, it does have to care somehow about whether Python is on the path, which was the question. So I think that's the answer must be that yes, it cares about it being on the path, but you can override it by using the DLL approach. I hope that makes sense. And I'm also trying to work with NI on getting more info on this. Eric asked a question: if you specify the DLL path in LabVIEW 2021, you can effectively use a virtual environment. Yes, if you use the embedded Python where the DLL is included, which is part of it, but the virtual env file, or if we go here again and have a look at this folder structure here, the virtual env that we created using virtual env. This scripts folder here was where I would expect the DLL file to be, but that's not taken care of by virtual env. It doesn't copy this to a new folder whenever it creates a new Python version or a new virtual environment. So basically, LabVIEW cannot look into this folder and see the DLL file that it needs in order to run the execute Python or open Python session. So that's why the presentation around or running the embedded LabVIEW with which is a full Python distribution inside a zip file, running that as your virtual environment instead, and then handling the installation of packages and getting pip to work on that system. That might be a better option, but it's just not documented from both actually on python.org. The docs there are somewhat vague about implementing this, and the LabVIEW documentation as well is could use a brush up on how to get this to work. So I would like to help out on that at some point with NI, and are in conversation with them on this issue. But basically, you could this folder here is basically all of your Python stuff could be these 78 megabytes or something like that, with packages and all that you need to put in here. And most of the things you could automate to run the right functions and things you need to do. So it is something that can be automated and shouldn't be done manually. But I just ran into the problem of actually running this DLL interface with the what's the name of it, with the part of LabVIEW and the LabVIEW nodes. So thank you for sticking around, even though there was a quiz. This was really fun to look into, and it was nice to finally have it presented online. I think that's it from me, unless there are any final questions. Thank you very much for your attendance. And I'll stick around for a couple of minutes for if there are any extra questions. And as I mentioned, feel free to add me on LinkedIn or write me an email if you have any further questions on this issue. I'll just put my contact info again. There. Good. Have a nice day, everybody.